Very good morning, friends. I welcome you all to my YouTube channel. Myself, Dr. M.H. Annaya. And friends, in today's video, which is number 302, we are going to draw the development of a hexagonal pyramid, which is cut by a section plane which is curved in nature, that is perpendicular to the plane of the board. And friends, they just give you a diagram like this with this radius. They have not specified what it is, but they will say about the size of this. They will say this is a pyramid of size 30 mm and height 70 mm is cut by a section plane as shown. Draw the development of the lateral surface of the part P, that is this part P, left over as shown. Friends, as usual, assuming that the pyramid is not cut by any section plane, you know how to obtain the development of this hexagonal pyramid. Friends, here if you just see this, we can mark the top view of this to the given dimension and number these as A, B, C, D, E and F. So friends, we have to darken all these. This is how the top view of the hexagonal pyramid looks. And I have shown all these slat edges. I will call this point as O, comma O1. O1 is the center of the base. That is O1 dash. O dash is the vertex. Friends, and these are the lines or the slant edges in the front view. We have got so many slant edges. That is 6 slant edges. Friends, let us transfer all these points to the front view. So this becomes A dash. This is B and F will come together. So we'll say B dash, F dash. This is E dash at the end. Then C and B will come together. C dash, comma, E dash will come together. And the center one is, we are not sure anything. So we'll take it up later on, the center of that. Now friends, I am going to draw the development of this pyramid, assuming it is not cut by any section plane. So obviously you will have in the development 6 triangular faces and all these triangles are isosceles. So friends, I will just mark a line here, mark a vertical line, a line. I have just shown this figure little bigger in size so that you will be able to mark all these correctly. Friends, here hexagon 6 parts. So we have to draw the arc. On the arc, we are going to make 6 divisions. That is with this radius R. I will say R. This is R, the total length. This is O, the apex of that. And here friends, same lines we are going to have totally 6 number of points on this curve and show all this by very thin lines. 1, second, third, fourth, fifth, and this is 6th. I got so many edges. Friends, we can start marking this, or before that, since it is a pyramid, let us join all these by straight line because all the base edges are straight. So we show by straight lines by very thin line. If it is a pyramid, we have to show by thin line. If it is a cone, we should not show that because it has got a curved periphery. Friends, let us mark this as A, B, C, D, etc. A, B, C, D, E, F, and A again. OA and OA have the length equal to, because if you see the figure, the front view friend, You have that is O dash A dash, and in the top you have got OA. OA is parallel to VP, and hence this represents the true length, which are represented as R. So this can be obtained only after construction of this pyramid to the given scale. You will be able to obtain what is R, and that R I have shown here. Friends, now let us start. Where all this section plane, the curved section plane is cutting the solid. Friends, O dash E dash slanted is cut here. O dash E dash is the true length. It has got same length R. So on O dash E dash, mark this height or mark this distance on O dash E dash. Friends, O dash E dash. You have this length, I'll just mark here. So this is a point on that O dash E dash. Then friends, you have got this point where the curved section plane is cutting OC and OE. But OC and OE are not the true length slant edges. So shift that point from here to the last line. That is the true length line. This is true length in nature. True length line. And measure that distance on OC and OE. Mark on OC and OE. So this was D. Made a small mistake. This is D. It should be. I should have done. Sorry. This is on the point D. This is OD. Is there now? OD. So now this is on OC and OE. Little below. OC and OE. Same distance is marked on this. Friends, the bottom, this end is cutting FC, sorry, BC and FE. Both BC and FE of the base are here. And if you observe the figure, this point where the section plane is cutting the solid is exactly between FE and BC. So exactly between FE, I just mark a point, and exactly between BC, I mark a point. And friends, these are the only points you have got. 2 on the base, 2 on the slant edges OCOE, and 1 point here on OD. Friends, we will just number them if required. We will call this as point 1. This is point 2, point 3, point 4, and point 5. This point is point 5 because there are different lines 1, 2, 3, 4, 5. And friends, let us mark them. On BC, it is 1 and this is 5 here. 1 and 5. On here, this is 1, comma 5. On OD, this is point 3. Then on OC and OE, they are points 2 and 4, 2, comma 4. The same points were transferred to the line here. Friends, now if you just observe this figure, the line OA is retained, OB, OF are also retained. So I will show this OA by a full line. OA, this OA is also to be shown by a full line. There is a visible line. And friends, OB, OF are also retained. This is OF and this is OE, OF and OC. Sorry, this is a point over OB and OF. OB and OF. So OB is here. I will join these two by a straight line. This is the remaining edge on that. And then friends, whatever the points you have got here are to be joined by a smooth continuous curve. So here friends, from here this is point 1. This is on a flat surface. This is also on a flat surface. And all these are to be joined by a curve like this. So friends, This part above the section plane is retained. So I have to show all this by dark lines. Friends, this is, and these lines should be shown by very thin lines, or they can even be removed from this section. Friends, here for the bottom face, this AF and point up to this phi to be shown by dark line. I am just making this little more dark, and this part is retained. This part is also existing. I am showing by dark line, and all these dark line. I will show again by the same color. Show dark line, a dark line or a visible line. Friends, this is how the development looks. 0, A up to here, then this arc, again B, A and this. So I will say this is the development of P, the lateral surface of the hexagonal pyramid when it is cut by a section plane which is curved in nature and it is perpendicular to the plane of the board. Friends, I hope the presentation was interesting, and please go through the video. If you like this video, do share with all your friends without fail. Thank you, friends. Have a nice day.